I believe that you all have understood my previous class topics. I hope you all are safe back at home. Now let's start with our next topic, resistance. Already we have studied. Go through the slide. Resistance is the property of a conductor to resist the flow of current through it. Look at the slide. According to Ohm's law, we know that R is equal to V by I. The SI unit of resistance is ohm. If the potential difference across the two ends of a wire is 1 volt and the current flowing through it is 1 ampere, then the resistance R of the conductor is 1 ohm, since I is equal to V by R. The current flowing through a resistor is inversely proportional to the resistance. So if the resistance is doubled, the current gets half. Note the point. If the resistance is doubled, then the current gets half. Okay. So the next topic, the factors on which the resistance of a conductor depends. Okay. Now try to investigate the factors on which the resistance of a conductor depends. Set up the same circuit in the previous slide. Set up the same circuit as we did to verify the Ohm's law. The first point, replace the wire AB in the previous diagram. Replace the wire AB with another one of the same material and thickness but of double its length. Measure its resistance by measuring V and I. It is found that the resistance of the wire is double that of the wire AB. This means that the resistance of a conductor is directly proportional to its length. Okay, I repeat. Replace the wire AB with another one of same material and thickness but of double its length. Measure its resistance by measuring voltmeter and ammeter readings. It is found that resistance of this wire is double that of wire AB. This means that resistance of a conductor is directly proportional to its length. Okay. So the next point, replace the wire AB with another wire of the same material and the same length but half its cross-sectional area. The resistance of this wire is measured by using the relation R is equal to V by I is twice the resistance of AB. This means that resistance increases with the increase in cross-sectional area. Resistance increases with the increase in cross-sectional area. So, look at the slide. First point, the resistance of a conductor depends on its length, area of cross-section, and the third one is material of the conductor. Okay. Which means the third point is the resistance of a conductor depends on nature of material. Which means we replace AB, the resistance wire AB, we can use it in verification of Ohm's law. They replace AB with a wire of same length and same cross-sectional area but of some other material. It is found that the resistance of this wire is different from that of wire AB. At the point, the resistance of a conductor depends upon the nature of its material. Okay, so The first point, the resistance of the wire is directly proportional to length. The second point, resistance of the wire is inversely proportional to cross-sectional area. And the third point, resistance of the wire is depends on material. So, look at the diagram. R is proportional to L, then R is inversely proportional to A. So, R is directly proportional to L by A. So, taking a constant, that is R is equal to rho L by A, where rho is called a constant of proportionality, or it is otherwise called resistivity, or it is otherwise called specific resistance. Okay, then I repeat, R is proportional to L and R is inversely proportional to A, then R is directly proportional to L by A, taking constant, that is R is equal to rho L by A, where rho is called the resistivity or specific resistance. Okay, the SI unit of resistivity is ohm meter, where ohm is the unit of resistance. Okay, ohm meter is the unit of resistivity. Okay, students. So, conductors like metals, alloys have low resistivity, that is equal to 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Note the points. Conductors like metals and alloys have low resistivity, 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Then insulators like rubber, glass, etc. have high resistivity, 10 raised to 12 ohm meter to 10 raised to 17 ohm meter. Okay. So we are go through the problems. We going to the problems. The first problem is calculate the amount of work done to carry 4 coulomb of charge from a point at 100 volt to a point at 120 volt. Okay, so here the charge of the is given, here the charge is given and the potential is given. Okay, we know that potential difference between 2 points is the V is equal to higher potential minus lower potential, that is 120 volt minus 100 volt, which is equal to 20 volt. Okay, we know that charge Q is equal to 4 coulomb. Coulomb is the charge of, the unit of charge. If the W is the amount of work done, we know that, listen, V is equal to W by Q, then W is equal to QV, that is 4 into 20, that is equal to 80 joule. Okay, clear? Then the next problem. What is the resistance of an electric arc lamp when hot if the lamp uses 20 ampere when connected to a 220 volt line? Okay, listen here. I repeat the question. What is the resistance of an electric arc lamp when hot if the lamp uses 20 ampere when connected to a 220 volt line? Okay, here the given data is potential difference V is equal to 220 volt and current through the lamp I is equal to 20 ampere. So we know that from Ohm's law we can write V is equal to IR, then R is equal to V by I, which is equal to 220 by 20 is equal to 11 ohm. Clear? Okay, so it is an application of Ohm's law. It is a problem coming from Ohm's law. Okay, next the third problem. Calculate the potential difference required across a conductor of resistance 5 ohm to make a current of 1.5 ampere flow through it. So calculate the potential difference required across a conductor of resistance 5 ohm to make a current of 1.5 ampere flow through it. Here the resistance of the conductor is given. R is equal to 5 ohm. Required current I is equal to 1.5 ampere. So we have to find the voltage or the potential difference. We know that from Ohm's law, V is equal to IR. I is equal to 1.5 and R is equal to 5 ohms. That is 1.5 into 5, which is equal to 7.5 volt. Okay, clear? The next problem, okay. Um, a torch bulb, when cold, has a 1 ohm resistance. It draws a current of 0.3 ampere when glowing from a source of 3 volt. Calculate the resistance of the bulb when glowing and explain the reason for the difference in resistance. Okay, repeat. A torch bulb, you know that torch bulb. A torch bulb, when cold, has 1 ohm resistance. It draws a current of 0.3 ampere when glowing from a source of 3 volt. Calculate the resistance of the bulb when glowing and explain the reason for the difference in resistance. Okay. So we go through the given data. Here the potential difference V is equal to 3 volt. Current through the bulb when glowing I is equal to 0.3 ampere. then the resistance of the bulb when glowing, we know that from Ohm's law V is equal to IR, then R is equal to V by I, which is equal to 3 by 0.3, which is equal to 10 ohm. Okay. If the resistance of the filament of the bulb increases from 1 ohm, that's been called 1 ohm to 10 ohm, in brackets, when it becomes hot and glows on account of an increase in temperature. The point, note the point, the resistance of the filament of the bulb increases from 1 ohm to 10 ohm on account of an increase in temperature. Note the point, when temperature increases, resistance also increases. When temperature increases, resistance also increases. Okay. The last problem in this section, a simple problem. Okay, how much current does an electric heater draw from a 220 volt line if the resistance of the heater is 50 ohm, 50. Okay, listen, we will move on to the given data. Okay, potential difference V is equal to 220 volt and the resistance R is equal to 50 ohm. Using Ohm's law, I is equal to V by R, that is equal to 220 by 50, which is equal to 4.4 ampere. Okay. Then we are move on to the next topic, resistors in series and parallel. So we know that resistance which oppose the current flow. Okay. Okay, listen. We have to connect one or more resistors in a circuit for practical purposes. The resistors can be joined either in series or in parallel. Series combination is used when the resistance in the circuit is to be increased or current is to be decreased. Note the point, series combination is used when the resistance on the circuit is to be increased or current is to be decreased. In parallel combination, on the other hand, is used when the resistance in the circuit is to be decreased or current is to be increased. Okay, so we have discussed in detail. The first one is resistors in series. Listen. Okay. A number of resistors are said to be connected in series if these are joined end to end and the same current flows through each one of them when a potential difference is applied across the combination, which means in short, in series connection, resistors are connected to be end-to-end connection. Here, three resistors R1, R2, R3 are connected in series, which means they are connected in end-to-end. They are connected to end-to-end connection. Note the point, end-to-end connection. And the total current flows through the each one of the resistor is equal. Okay, in series circuit. Okay, listen the point. In series circuit, the current in each resistors is equal, but the potential difference in each resistor is different. Current in each resistor is same and the potential difference in each resistor is different. Okay, look at the diagram. Three resistors R1, R2, R3 are connected in series. Okay, let I be the current flowing through this combination. I be the total current and current. I be the total current and the current for each resistors. Okay, for example, pi is equal to 2 ampere. The 2 ampere current flows through each one of the resistors. That is the point. Okay, the 2 ampere current flows through each one of the resistors. Okay, I repeat, in series circuit, resistors are connected to be end-to-end connection, and current in each resistor is same and the potential difference is different. Okay, look at the diagram. R1, R2 are the three resistors. V is the potential difference across A and B. Okay, then V1, V2, V3 are the potential difference across R1, R2, R3 respectively, which means V1 is the potential difference across R1, V2 is the potential difference across R2, and the V3 is the potential difference across R3. Okay, then it is clear that total potential difference is V, total resistance is Rs. Look at the diagram B. Total Rs is the total resistance when resistors are connected to be in series. Okay, then it is clear that V is equal to V1 plus V2 plus V3, which means V is equal to sum of potential difference across each of the resistance. That V is equal to V1 plus V2 plus V3. Okay, then we know that according to Ohm's law, V1 is equal to I into R1, which means I is same for all. Then R1 is the resistance of first capacitor. Then potential difference across resistor R1, that is V1 is equal to I into R1. Okay, clear? Then potential difference across resistor R2, that is V2 is equal to I into R2. The next step, potential difference across resistor R3, that is V3 is equal to I into R3. Okay, clear? That is V1 is equal to I into R1, V2 is equal to I into R2, and V3 is equal to I into R3. Clear? Then take Rs be the total resistance of this combination. Okay, then we know that I is the total current of the circuit and current for each resistor. Then Rs be the total resistance. We know that is V is equal to I into Rs. So listen to that point. Listen to that step. Okay, V is equal to I into Rs, which means V is the total potential difference. I is the total current and Rs is the total resistance. So we can write according to Ohm's law, V is equal to I into Rs. I repeat, V is the total potential difference and I is the total current and Rs is the total resistance. Then we know that V is equal to I into Rs. From equations 1 and 2, listen. I into Rs is equal to I into R1 plus I into R2 plus I into R3. Just listen to first step. V is equal to V1 plus V2 plus V3. We replace V as I into Rs. Listen. Then we replace V1 as I into R1. Then we replace V2 as I into R2. Similarly, V3 as I into R3. So we cancel I. Then we get Rs equal to R1 plus R2 plus R3. Okay. Rs, that is Rs is the total resistance, R1 is the resistance of first resistor, R2 is the resistance of second resistor, then R3 is the resistance of third resistor. That is Rs equal to R1 plus R2 plus R3, which means when three resistors are connected to in series, the total resistance is the sum of individual resistance. Note the point. If when a number of resistances are connected in series, the equivalent resistance or the total resistance is the sum of individual resistance. Okay, clear? So, okay, then we are going to study about resistors in parallel. So it's a simple topic. Okay, then listen. Here we connect, if one end of each resistor is connected to one point and the other end is connected to another point, so that the potential difference across each resistor is the same and is equal to the applied potential difference between 2 points. Make it clear. In series connection, we are connected these resistors in end-to-end connection. In end-to-end connection. In parallel connection, if one end of each resistor is connected to one point and the other end is connected to another point, so that the potential difference across each resistor is same and is equal to applied potential difference between 2 points. Clear? In this, the current across each resistor is different and the voltage across each resistor is same. Okay, so listen to 2 points. First one is, in series connection, current in each resistor is same and potential is different. Potential difference is different. In parallel connection, current in each resistor is different and the potential difference across each resistor is same. Okay, then look at the figure. 3 resistors R1, R2, R3 are connected in parallel. Okay, let I be the total current flowing through the circuit, then I can be divided into I1, I2, I3. Okay, the total current I, for example, I is equal to 8 ampere. That is 8 ampere current is divided to 3 resistors. Okay, let I be the total current. I can be divided into I1, I2 and I3. Clear? Then RP. Then the second I, look at the second diagram. Let RP be the total resistance when it is connected in parallel. As we studied earlier, when Rs is the total resistance across series combination, here Rp is the total resistance when it is connected in parallel. Okay, so listen, we know that first step R1, R2, R3 are the three resistors. Then V is the potential difference across the points A and B. Let I be the total current flowing between the points A and B. We know that I1 is the current flowing through resistor R1. I2 is the current flowing through resistor R2. Then I3 is the current flowing through the resistor R3. Okay, which means R1, R2, R3. The I1, I2, I3 be the current flowing through R1, R2 and R3. Clear? Then move on to the first equation. I is equal to, we know that the total current I is divided to each of resistor, which means I is equal to I1 plus I2 plus I3. Clear? Okay. Since potential difference across R1, R2 and R3 is the same, that is, according to Ohm's law, V is equal to IR and I is equal to V by R. Okay, the first equation, I1 is the current flowing through resistor R1, that is I is equal to I is equal to V by R1. Then second step, the current flowing through resistor R2, that is I2 is equal to V by R2. Then I3 is the current flowing through resistor R3, that is I is equal to V by R3. I repeat, I1 is equal to V by R1. We know that potential difference across each resistor is same, that we taken as V. That is I1 is equal to V by R1, that is I2 is equal to V by R2, and I3 is equal to V by R3. Okay, let Rp be the total resistance or equivalent resistance. Okay, it is clear that I is equal to V by Rp. I is the total current, V is the total potential difference, and Rp be the total resistance. Okay, that is the total current is equal to total potential difference by total resistance. That is I is equal to V by Rp. Clear? Okay. From equations 1 and 2, we can write that V by Rp is equal to V by R1 plus V by R2 plus V by R3. Clear? V by Rp is equal to V by R1 is R1 plus V by R2 plus V by R3 from equation 1. Okay, so we cancel V, then we get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, where Rp is the total resistance. I repeat the final equation. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, in series connection, total resistance Rs is equal to R1 plus R2 plus R3. In parallel connection, total resistance is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Thank you.